Good morning, everybody. Welcome to our session on external objects for external big data. My name is Sumit Sarkar. So I am the Chief Data Evangelist at Progress. So part of my job is to explore some of the latest technologies, emerging technologies, and I'm going to share some of the things I've learned exploring big data. Can you hear okay? A little louder? Okay, better? Thank you for sharing. Okay. If you can't hear, raise your hand in the back, or we'll come and sit up closer. So we're going to explore big data objects that we've explored at Progress, and a lot of things we've learned around this project. And Progress is a software company. We are a Service Cloud and Sales Cloud user, and so we'll show you what we did with integrating big data into our orgs. Okay, so on the agenda, we're going to introduce what external objects are for big data. We'll talk about what Salesforce Connect is. We'll just talk about big data. That's a term everybody talks about, but we'll talk about the context of what we did with Salesforce. Then we'll talk about what OData is that bridges the two together. Then we'll follow it up with how to access that data from Salesforce. With a live demo, I've got my fingers crossed because who knows how these things go. And then we'll follow up with some of the lessons we've learned so that if you're exploring a similar project, you won't hit the same things we ran into. It's just so I get a survey of the group here. I guess there's two types of people in the world, as those who kind of work more on the Salesforce side of the house, and those who work more on the big data side, maybe infrastructure, on-premise stuff. How many of you guys are more Salesforce people? Okay. What about big data people? Okay. Good to see the show of hands. All right. So this presentation will talk to both of you at different levels, so I'll keep that in mind on who's where. All right, so let's start out by talking about what is Salesforce Connect. How many of you have heard of the Salesforce Connect? It was formerly called Lightning Connect. Okay, pretty much everybody. All right, so for those of you who didn't raise your hand, Salesforce Connect, it maps Salesforce external objects, which is a feature that was released, I think, in winter 15. And that maps those external objects to data that resides outside of Salesforce. So things like the big data piece here, databases, anything outside the platform. And they're accessed on demand. So the data is not stored in Salesforce, rather it's stored off the platform. And this is pulled out of their help desk and out of the help books. And when it's recommended when you have a large amount of data that you don't want to copy into your Salesforce organization. So obviously, this is a great use case for big data, and especially because I don't want to copy my big data into the platform. And in the screenshot, you can see you've got sales orders in the bottom right. And that's really external objects. So when you load this page, it has a relationship to accounts, and those sales orders are coming from maybe an Oracle database, a SQL Server database, something off the platform. And that data is loaded when you load the page, and when you close the page, the data is wiped out of memory. So that's what external objects are really bringing. All right, so what is big data? This is a fun question to ask, but in the context of Salesforce, Salesforce uses, on the other side of their platform, there's a lot of big data stuff going on back there. They have HBase, they have pig scripts, they have Hadoop clusters, and they have Phoenix as a Apache project to access data. I think Salesforce came up with. So all that stuff's happening behind the scenes. It might power things like Einstein, which we'll talk about at Dreamforce. And if you play with big objects, that's exposed. That's actually stored in HBase and exposed to our big objects API. So that's big data in the context of Salesforce. But in this presentation, we're going to talk more about big data platforms. So we think about the stuff on the right side. Maybe you have a Hadoop platform at your organization, or you have something running in the cloud. So at Progress, we have a Hadoop cluster running our data lake. But so these technologies on the right are big data. There's either Hadoop, or at the bottom, you've got some of the NoSQL databases like Mongo and Cassandra, or even Spark SQL, which is a really hot big data open source project. So all that stuff is what we're talking about with big data, and connecting that from the Salesforce platform. And I say don't ETL big data sets into the platform. Our Salesforce folks will yell at me if I start loading gigabytes of data into our production org. So when you have really big data sets with big data, this is detailed data, right? It's not necessarily each byte's of high value. So you want to store that off the platform, not on the platform. And love to hear anybody afterwards if you have projects. And if you're what you're trying to do with big data, very curious. All right, so how does my team at Progress use big data? So we use we use a Hadoop cluster, and we're actually loading a bunch of customer and marketing data and application user data from different systems we have. We're a Salesforce shop. We have Sumo Logic for cloud logging. We have Eloqua for our marketing activity data. And obviously, Google Analytics is how we track our web visits and digital presence. So we bring all that data into this Hadoop cluster, this data lake. We're just bringing raw objects in. And we're really doing things to enhance the customer journey. So if you try one of our products, we can tell what kind of pages you're visiting, what kind of success did you have with it, how successful is your evaluation based on what Service Cloud articles you're reading and things like that. We can also figure out what other products you might be interested in based on what you read or viewed or accessed. So we can give you better targeted email campaigns and things like that. I hate getting emails of nothing I care about, so this is really important to us to make credible emails to a technical audience. And then success scoring. We have a lot of leads coming in, and we want to make sure we're routing the right ones to the right places. So sometimes we have lead scoring and we do ourselves, but sometimes when you take this 360-degree view, you get a different score, and it gives us a lot of insights into what people are doing, and we can better have sales follow up. Like if you come to Dreamforce, you get your badge scanned 1,000 times, we can tell if you really want to talk to somebody or not by trying to analyze some of this data. All right, and the reason we built a data lake, if you're not familiar, that's just loading raw objects into a Hadoop cluster or some other data repository. So we chose that approach because we didn't necessarily know what questions we're going to ask of this data. We also wanted the scalability of Hadoop, so as we load more and more data into this, we can continue to scale out. And also, it's important to let our own folks who have different skill sets to access that data however they like. So for that success scoring, we've got people who may like to write in R and build out some models and things like that for predictive purposes. So this is really valuable, the data lake approach. All right, so what is OData? So OData is really the bridge between, we talked about Salesforce Connect that accesses external data. We talked about big data. So OData is the thing that bridges the two together. And it's a interoperable REST API. Some people call it SQL for the web. You can think of it as SOCL for the web. But it's an OASIS standard, so it's adopted by independent of any particular vendor. It started by Microsoft, but now Salesforce has adopted it for Salesforce Connect. SAP has adopted it. Microsoft. So a lot of different folks are leveraging OData as well as Progress. And just, it's a REST API, has uniform URL conventions I'll show you in a moment, and it surfaces metadata in a uniform way. So if you think about accessing external data from Salesforce, that's really important because if you just point to any web service, you may not know what the data model looks like, but OData provides that, which is partly why Salesforce chose this approach. And as a software company, we're also on the OData technical committee, so we try to drive that standard forward. And Salesforce is a big user of that right now. Okay, when we look at OData URL conventions, if you look at this, if you're SOCL developers, for those people raise your hand if you work on the platform or maybe you work with SQL, OData provides a uniform way to query data. So you can see the entire query is actually part of the service URI. And when you run a SOCL query, you might have like some query equals and then you pass in your SOCL query, but this is actually built into the URI. And so you see at the bottom, you have a service root URI, a resource path with her products in this case, and some filter options. And those options are here in the, we have things like select. In SOCL, you can select some fields and objects. Very similar concept in OData. You can do equality filter, things like that. Give me the address city that's equal to Redmond. Or you can do order by operations. You can ascending and descending order. Expand is a way to go between entities within OData, so it's entity model. So if you have a relationship between an external email ID and an external account ID, you can navigate that through these relationships with the expand clause, and top and skip. These are all kind of parts of the OData query. You can write this query against anything that supports OData, and it will provide you an answer. So that's the quick rundown for folks who care about SOCL and SQL. All right, so from a Salesforce perspective, the way, the first thing you do is you get your big data system set up, then you have to produce OData from it to access it through Salesforce Connect. So we're using Data Direct Cloud Service because it's from Progress, and it's a popular service for Salesforce Connect shops. And it's firewall friendly, so as a person maybe works on a Salesforce platform, you don't have to worry about your VPNs and reverse proxies and all that stuff. You can expose OData through this service. And it supports more Hadoop distributions than any other OData service available. So that's the approach I went with. You can also look at the Apex connector framework. That's an SDK built by Salesforce if you want to build something yourself. We didn't have a web service API built on top of our Hadoop system, so that I didn't have time to really run with that, but it's also an option. There's open source technologies as well that can get you part of the way there. I think Heroku has a project that can help you get started on some of this stuff, but it won't help you necessarily traverse the firewall. So lots of options, but the key is you need OData to make this connection through Salesforce Connect. All right, and then, so I showed you a little bit about our data lake. So then the next step is we want to connect Salesforce to that lake for our CRM users or our Service Cloud users. So we decided, how can we take this project really to the next level? We're doing a lot of cool stuff. So we're doing stuff like success scoring, personalization. We have archives of all our histories, 360-degree views of data, all this nice stuff that we're building the data lake. People are crowdsourcing and doing neat stuff. But how do we expose this insight back to our Salesforce users in the Service and Sales Cloud? And so that's really what we're exploring. And I'll show you a demo of how this is working. And so it's kind of neat because Salesforce, during this exploration process, Salesforce kind of becomes I know it's like the Gartner word system of engagement for our big data Hadoop lake. Because a lot of our Salesforce users, they don't want to touch the Hadoop lake and they don't really care. They just want to get their data, ask some questions and things like that. So it works out really nice to have Salesforce as your front end. You get mobile, you get all the bells and whistles of the Salesforce platform. So that was really nice. All right, so let's look at a quick demo. So we're in the Dev Forest. Demos are nice to check out. So we'll show you, what I'll show you is, we have Salesforce in the top left, and the Data Direct Cloud Service is the one I talked about that produces OData for us. And that's what helps us. It has a piece that runs behind the firewall. We call that the on-premise connector. And that's what provides that access to Salesforce. And it uses firewall-friendly protocols like HTTPS and UDP to get through the firewall. And then it has a connection to all the Hadoop systems. So we'll show you how this all works end-to-end, bringing data from Hadoop, and then surfacing it to Salesforce using our service. All right, so let's see what luck we have today in getting stuff to work. All right, so this is my dev org. Progress won't let me use production stuff at Dreamforce for obvious reasons. So let me just show you what the external objects look like. All right, so we're going to do a search external objects. So here's all the external data sources I've configured. And if you have a dev org, you can get access to Salesforce Connect. And so you'll notice I've got a couple of things configured, but I've got this Hadoop is the data source for my data lake that we talked about earlier. And so if I can click into this data source, we can see what objects we have. And one thing I will show, you can note this DD search custom option for Salesforce search. I'll get back to this later on why I did that, but make a note that I had to set something up there. And then here's I just exposed 2 objects for today from the lake, and we're going to look at emails opened. So this is like every email we've ever sent out from Progress. Are spamming all you guys every day, and it tells you whether you opened it or not. And that's low-level detail that we want to surface to sales groups. And so when we look at this data, right, you have this API name of __x because external is going against our Hadoop system, and it reverse engineers all the Hadoop Hive data types into Salesforce native data types. The Salesforce Connect is really cool for that. Makes the data look very much native to the platform. And then I've got a lookup in our lake. I have a contact ID, which is related to some of our master objects in Salesforce. And so this is how this external object is configured. And then let me actually click on this guy. All right, so this is a contact. Chris Harris actually works for us, so this is not sensitive customer data. He's actually out there somewhere, not sure where. But if you go to the bottom, we have this related list of emails open. And you can see it's kind of crunching here, like loading this big data set. But it's not loading it because it's slow and it's too much data. It's taking a bit of time because it's running a MapReduce job, and this is our non-prod environment, which is pretty slow. So it takes a couple of seconds to load here. So in our non-prod environment, it takes about 20 seconds to load. In production, it takes about 5 seconds to load. But I'll give you some more. Let me go into this, what that connection looks like while that's loading. So this is the Data Direct Cloud service that I use to configure it. So I'll walk you through what that looked like as well. And so this is running in the public cloud. This is a commercial product we have and we sell to other customers. And if we click on data sources, you can see it supports a number of different things. So it can produce OData from any of these things for Salesforce Connect. It's effectively a Salesforce Connect service in a lot of ways. So I've seen a lot of, if you read online, you can find customers using it for things like Oracle, SQL Server, Eloqua, Big Data, Postgres, Redshift. Those are really popular data sources. We also hear a lot about SAP, but we're not an SAP shop, and we don't support SAP, but that's also a popular one. So these are data sources, and I configured one with Hadoop. So let me go back to that and show you what that looks like. So this is my data lake. And so what happens is with this, I'm configuring a connection to our Hadoop system. You give it a physical host and port. But remember, we installed that piece, the connector behind the firewall. So it's really, this is a TCP connection from behind our firewall, and then the service takes care of the rest of it. And when you install the on-premise agent, it gives you a connector ID, which will register with the service. And so that's what the connection details look like. And so when I get this configured with OData, you click on the OData tab, and it gives you the URL. You just take this, you paste that in Salesforce, and you're off and running with external data. And just to show you what entities are out there, again, this is going to be, it's using the Hive interface of Hadoop. So it's doing like HCatalog. So it's running against a schema. It takes a moment here. And email open is the category, the object I exposed from the lake. It'll take a second to load here as well. Again, slow dev system. But let me take a look and see. So this is the data that it pulled. It took a couple of seconds here, but it pulled all this from our lake, so we can see externally, what for this particular contact, what emails did we send him? What did he open? What did he not open? So these are kinds of things that we're able to relate from a lake, right? Each individual activity may not be of great value, but when you can reference it or look at it on a large scale, it makes a lot of sense to have access to this data. Then back to this, so here's the object, email open. And so you have to set a primary key on this unique ID, activity ID. And then there's a little button here called make it searchable subject line. So that's the subject of each email. And so by clicking this in our service, remember I showed you that DD search field? That's basically telling Salesforce, only search this column. If you don't do that, this is what happens with other OData feeds, is that it's going to do like a MapReduce job on every field you have, and it's going to take you forever. So we'll talk about, we'll re-hit that point in a moment about search. Okay, so that's the OData entity I've configured. I just exposed one. And cancel that. And so that, we copy that URL, put it back into Salesforce, and if we go back here, so I'll show you one more quick one, just in case if you're new to Salesforce Connect. This is an object, an account object. It's pulling from our SQL Server orders database, and that one loads up right away in seconds. So I want to point out the latency you saw is because of the MapReduce jobs in our dev environment. It's not because Salesforce Connect is slow. So from a SQL Server type of system, it's much faster. Okay. All right. So let me get back into my presentation here. All right. So that's again, we showed you. When I was on that Salesforce screen with accounts, with the contact and the account, it was in Salesforce, and it makes that OData query to our cloud service, and the cloud service brings that data, surfaces it back through OData based on those objects or entities I exposed in this service. And I showed Hadoop and SQL Server just to contrast the different latencies. Okay, so let me then walk through lessons learned. I think this is, it's not necessarily anything went wrong, but do want to share like what we saw in this project. Okay, so there's a lot of them here. So what we learned with exploring this technology, so the first thing is mapping those OData entities to big data objects. So if you think about a data lake, we're talking about dumping raw objects into this lake. And so that's something we need to think about. First, we need to think about, does it have a unique column? Because with OData and Salesforce Connect, you have to have uniqueness in that object, external object. And so if it didn't, you have to do a composite key where you select more than one. And so I would argue there's probably not too many data sets that don't have a composite key. Definitely in our lake, we had uniqueness on just about every object. But then also, you can have a max of 4 joins, I think, through Salesforce Connect. So if you have a lake with a bunch of stuff, you might want to think about joining it maybe joining the lake versus joining it in Salesforce, because there are some limits in joining across multiple objects. So that was an interesting point that we ran into. I talked about the primary keys a little bit, so I think I mentioned that about you have to have a primary unique key or a set of composite key of multiple keys across these big data sets. In Hadoop, I don't think it does a whole lot of enforcement, so there's some different big data technologies, different query interfaces will have different levels of support to make these unique. And then when we look at concurrency, so I'm using Hive Server 2. Hive Server 1, I believe, allows it's limited on concurrency. So if you're going to have a Salesforce environment, you need to plan for that and have multiple sales users hitting these objects. So you need to think about concurrency. Hive Server 2 works really well. There's also other technologies out there that can be set up for maybe lower latency and lots of users, right? So that's one area that we explored with Hive Server 2. And on the point of Hive Server 2, so one other thing maybe someone in the audience knows, I couldn't find a good test utility to really hit my objects and simulate the Salesforce environment. I know you can do it with Apex callouts, but I looked at a tool called, this company got acquired, BlazeMeter, I think, and you can set up unit testing against this OData feeds, and you can kind of simulate a bunch of Salesforce users hitting that. So that's another approach we saw that we could try. And then with external objects, there are limits if you haven't explored it. So you can, by default, you can query about 50,000 records per hour, I believe. But if you want to query more, you can set it up for fast, I think it's high performance or high load. There's a button you check, and then you can access data more quickly. I saw a blog by Alba Rivas from Financial Force, and she actually walked through and did a benchmark between default and the optimized high performance views, and you can see it's faster. But you lose the ability to use Salesforce 1 and other things. So there's a trade-off with that. And then there's a 2-minute max timeout. By default, I think it's 60 seconds. So if you do have really large data sets that are really crunching, it's going to time out in 2 minutes. And again, that's not a good experience anyway. So, but it's something to consider, especially in a dev environment where it's pretty slow. So we had stuff timing out. And the search has a similar timeout feature. So another interesting thing for us was to use native Salesforce reporting, and that's going to be available in winter 17. If you're in the preview org now, you can play with it. And so there's some other things. We wanted to explore that, but I didn't get my preview org enabled in time, so I didn't get a chance to play with it much. But that will be really interesting for us, because then I think that fast data load stuff will make more sense, because the demo I showed you is more accessing reference data, but that would be accessing report-style data, so a lot larger data sets. And I know you can get your org enabled to access more than just the 50,000. You just have to talk to Salesforce. Search considerations. Remember, I had you guys mentally note that DD search parameter in the configuration. And then that timeout limit, again, is 2 minutes. So when you don't, again, by default, if you don't have that thing configured, it's going to do in full index scan, to full table scan across all your string fields in a big data set. So that sounds pretty scary. So this search feature is really important. So that way, when you search these big data fields, like if I want to search every email we send out and search the text of them, I can do that and just filter which fields I specifically want to search only. And I think I ran into a bug with that. It seems like the timeout is happening before 2 minutes, but I'll have to report that to Salesforce. And then with OData services and lakes, the nature of a lake is we put raw objects into this lake, but we have a bunch of people working on this thing, finding different insights. And so every day we find new interesting things. Our sales and service cloud people want to access new and interesting data. So it really helps to have this kind of point-and-click, drag-and-drop OData service. Otherwise, I have to recompile, manage a REST API endpoint, and all that stuff. So I found that to be really useful with the lake so far in our exploration. Governance and masking. This is a data integration topic for the people who raise their hand or more on the big data side. But we had PII data that we're loading into this lake, and so our IT didn't want us. We're still exploring. We had to mask all of our PII data, email addresses, names, things like that. So we had to do that before we loaded the data into the lake and make it accessible to Salesforce users. And then the CRM experience, we're still exploring, but we need to. You saw in my dev environment, it was a couple 20 seconds. But even at 5 seconds, the sales folks and other folks using our CRM system are going to run out of patience pretty quickly. Even though it's amazing to have access to big data sets, it's still not good enough. So we're going to see what we can do about that. So one thing we look at is with the design patterns for external data. By default, when I load that contact object, it's going to start to query that Hadoop data lake. But by default, there's this feature, what does it say there? Enables separate loading of related lists for external objects. So if you check that, the page is going to render before that big data set is finished. So that was really good, because otherwise it'll be sitting there for a couple of Mississippi, and that's not a good sign for this. So that's really good. And then also a design pattern probably is to opt into that data versus always loading it by default, depending on your use cases and how fast you get it. And there are some articles on performance tuning. I just showed related lists, but obviously there's a lot of different use cases and patterns we're still exploring. And then for those people who raise their hand, they're more on the big data side. We, originally, in our production environment, we've got this thing humming along nicely. We did a lot of different strategies. I think there's I forgot the name of the project, that Apache project trying to speed up Hadoop Hive access. But we changed the query execution engine to use Apache Tez. We're using the ORC files, which is a new binary storage format to make data access faster. You can use vectorization queries. It starts in Hive 0.13. And there's a lot of different, this gets into the big data tuning side of things. If you're a Salesforce user, it says stuff Salesforce people don't care about, so cover your ears. But you can start doing partitions, indexes, buckets, block size, all these different things that the big data infrastructure people will take care of. But the message is that you can find a low latency solution that's going to be fast and responsive. And so we're going to start exploring other query interfaces. Because with Hive, that was originally designed for batch. We've got it, the open source community has it going pretty quickly now. But there's also a lot of other open source and commercial solutions to make that query interface much faster and operate more like a SQL Server database. Something like Apache Hawk is an example of something we might look at as well. Some resources. So if you're getting started with this stuff, I have no idea who that lady is. It's from the sample deck, but Salesforce Connect, new to it, go out to the help page, read more about it. It's really cool technology, and I think it's really helping Salesforce orgs have that one version of truth, keep their data where it lives. There's a tutorial on the Salesforce developer site. If you go to that bit.ly get x data, you can take a look. It walks you through a 5-day proof of concept. It's actually one that I wrote on how we connected our data warehouse with our org. It walks you through each day, what I had to do, who I had to talk to. It's a good idea if you're starting to explore this stuff and you're on the Salesforce side especially. And then finally, if you want to play with that cloud service, it's datadirectcloud.com. So that's that Salesforce OData service for external objects. And you can start accessing Hadoop and all these Oracle and other systems of record behind your firewall. I think thank you guys for hanging in there. I hope it was interesting to you. I'd love to talk to you guys afterwards. I've got 2 minutes. They kicked me off right at 2 minutes, so happy to take questions.